Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to Math Solver 1117. Today we are going to solve Class 12 Maths Model Paper by Federal Board for 2025 exam. In this video we will solve short question that are given in section B in the right hand side. In the previous video, we have solved all the short questions of the left hand side. That video link you will be find in the description of this video, and we have already uploaded the video of MCQs for class 12 maths exam. If you are new, subscribe Math Solver 1117 and also share the videos and also press the bell icon to get notification for all upcoming videos. Now we will start from question number 1. Now question number 1 is find the equation of following straight lines such that parallel to x-axis and a distance of 5 units below it, and in the B part perpendicular to the y-axis and passes through the points 6 and 4. Now we will solve this question in very easy and simple way. Now first of all we will solve parallel to x-axis and at a distance of 5 units below it. So you will write a line that is parallel to x-axis, has general form y is equal to c, where c is constant. Since in this problem he says that parallel to x-axis and a distance of 5 units below it, it's mean that the line is 5 units below the x-axis. So below the x-axis means this is your x-axis and below means on the y-axis, and here the value of y is negative. So you will write y is equal to minus 5. So the equation of the required line will be y is equal to minus 5. This is the equation you have to be find out. Now we will solve B part, that is perpendicular to y-axis and passes through the points 6 and 4. You have to find a line perpendicular to the y-axis is a vertical line, and its general form we will write. So you will write a line that is perpendicular to y-axis. Perpendicular to y-axis has general form, that is x is equal to c. So c is a constant, and since the line passes through the point 6 and 4, these points are given in the question. Since the line passes through the point 6 and 4, so you will just write the x coordinate, that is always 6. So your equation will be, the equation is x is equal to c, means x is equal to 6. So this is the equation you have to be find out in this question. Now we will solve question number 2. Now the question number 2 is determine the equation of tangent to the curve defined by y is equal to 2x square minus 7x plus 1 at x is equal to 2. So first of all you will write the equation of tangent, that is y minus y1 is equal to the m into x minus x1. Here x1 and y1 are the points of tangency. So To find slope, first of all we will find the slope. So you know that we will find the slope easily by differentiating this function. So dy by dx will be equal to the slope. So after finding dy by dx, you will put x is equal to 2 and get the answer, that is m. So after finding m, you will also find the point x and y and then put in this equation and solve this further. So first of all we will take the function, that is y is equal to 2x square minus 7x plus 1. This is your function. So now you will differentiate this with respect to x. So dy by dx, which is equal to the m. M is the slope and slope is always equal when you differentiate the function. So 2 into 2 is 4x minus 7. Now at x is equal to 2, you have to find the slope at x is equal to 2. So put here m is equal to 4 into 2 minus 7, that is 8 minus 7, m is equal to 1. So the slope of the given equation is 1. Now you have to find the point of tangency. So to find x1 y1, you will put value of y, that is 2x square minus 7x plus 1. So you will put the value of y equal to the, at x is equal to the 2. So y is equal to 2 into 2 square minus 7 into 2 plus 1. So 2 square is 4, 4 into 2 is 8 minus 14 plus 1. So 8 plus 1 is 9, 9 minus 14 is equal to the minus 5. So the points of tangency are x1 and y1 is equal to, x1 is 2 and y1 is minus 5. So these are the point of tangency. Now we will find the equation of tangent, and slope is also 1. So put these value in this equation. So y minus y1, that is minus 5. So it will become plus 5 is equal to slope, that is 1, and x minus 2. So make this simplify. Y is equal to x minus 2 minus 5, which implies that y is equal to x minus 7. So this is the required equation of tangent you have to be find out in this question. So you will write, this is the equation of tangent. Now we will solve question number 3. Now question number 3 is, test the continuity of the function, that is f of x, which is equal to 1 minus 3x when x is less than minus 6, and 7 when x is equal to minus 6 at x is equal to minus 6, and x cube when x is greater than minus 6. So to check continuity, you will check that your limits of the left hand side, right hand side, left hand limit, that means when x approaches to minus 6, negative, and right hand limit, which means that when x approaches to minus 6, positive, and third one is function value f of minus 6. If both limits exist and are equal to f of minus 6, then you will say function is continuous. So if limits exist and equal to f of minus 6, then function is continuous. So We will solve this. First we will find left hand limit, then find right hand limit, then find function value at f of minus 6. If three answers are equal to the 7, then we will say that function is continuous. Now we will find first of all left hand limit, which means that limit x approaches to minus 6 negative f of x. It's mean that we will use 1 minus 3x because this is on the left hand side where x is less than minus 6. So you will write the value of limit x approaches to minus 6 negative and 1 minus 3 of x. So put the limit in this, you will get 1 minus 3 into minus 6. So 6 into 3 is 18, 18 plus 1 is 19. So 1 plus 18 is equal to 19. So the left hand limit is 19. Now we will find the right hand limit by the same process, that is limit x approaches to minus 6 positive f of x. So function will be equal to x cube. Now apply the limit, means minus 6 cube. So minus 6 cube means minus 6 multiply minus 6 multiply minus 6. So 6 into 6 is 36, 36 multiply 6 is 216. So minus minus plus and then minus, so it will become minus 216. Now the value of function at f of minus 6 is equal to the 7. Now we see that limits are exist but not equal. Left hand limit and right hand limit are not equal and not equal to the value of the function. So you will say since 19 is not equal to minus 216, the limit does not exist. So function is discontinuous at x is equal to minus 6. Now we will solve question number 4. Now question number 4 is evaluate limit x approaches to 0, 1 plus x raised to power minus 2 minus 1 is by x. So we have to find the limit. For this purpose, we will expand using the binomial approximation. So you will write by using binomial approximation. You will get 1 plus x whole power is 9 is approximately equal to the 1 plus n of x, and condition is for small x. X is very small. So we will apply this approximation here. Here we have the n is equal to minus 2. So for n is equal to minus 2, 1 plus x raised to power minus 2 is approximately equal to 1 minus 2 of x. Now substitute this approximation here, you will get limit x approaches to 0, 1 plus x raised to power minus 2 minus 1 by x. When you put this approximation here, you will get 1 minus 2x, then minus 1 divided by x. Minus 1 and plus 1 are cancelled out. You have minus 2x by x, x and x both are also cancelled out. So you will say that as x approaches to 0, the expression approaches to -2. So this is the final answer of this question. Now we will solve question number 5. Now question number 5 is determine the fourth derivative of f of z which is equal to 9 sin z by 3 plus cos 1 minus 2z. We have to differentiate this function 4 times. So we will start the solution of this question. First of all, write down the function, that is f of z is equal to 9 sin z by 3 plus cos 1 minus 2z. So differentiate this with respect to z. So f dash of z is equal to the 9. 9 is constant. Sin differentiation is equal to the cos. So you know that dy by dx sin of x is equal to the cos of x. So you will use this here. It will become cos 2 by 3 z by 3, and then z has 1 by 3 also. So you will write 1 by 3 in the form of multiplication. Now you know that dy by dx of cos of x is equal to the minus sin of x. So this will become minus sin 1 minus 2z, and further differentiate 1 minus 2z, that is equal to the minus 2. So your required function will be equal to f dash of z by simplifying 3 into 9, 9 by 3, which is equal to 3. So 3 cos z by 3 minus minus will become plus 2 sin 1 minus 2z. Now we will differentiate this further because we have to find fourth derivative. So f double dash of z, 3 is fixed, cos derivative is minus sin, so we will use minus in the start, sin z by 3, and that is also 1 by 3 plus 2. Sin derivative is cos, so cos 1 minus 2z into minus 2. When you differentiate 1 minus 2z, you will get minus 2. So write this in more simplifying form. You will get this 3 and this 3 is cancelled out. So you have only minus sin z by 3 and minus 4 cos 1 minus 2z. So this is the second derivative. Now we will find the third derivative, that is f triple z, and sin derivative is cos, so minus cos z by 3 into 1 by 3, and then minus minus will become plus 4 sin of 1 minus 2z into minus 2. So third derivative will be equal to minus 1 by 3 cos z by 3 and minus 8 sin 1 minus 2z. So this is the value of third derivative. Now we will find the fourth derivative. So minus 1 by 3, cos derivative is minus sin. So this minus 1 by 3 will become positive, sin 2 by z by 3, and then further z by 3 derivative is 1 by 3 minus 8, sin derivative is cos, so 1 minus cos 2z, and then further minus 2. So 1 by 3 multiply 1 by 3 is 1 by 9. This is the fourth derivative. Sine z by 3 and minus minus is plus. 8 into 2 is 16 cos 1 minus 2z. So this is the final answer of this question. Now we will solve question number 6. Now question number 6 is convert the equation that is x square plus 4y square plus 2x minus 24y plus 33 is equal to 0 in standard form. Find the coordinates of the center, vertices, co-vertices and the foci. So we will solve this question in very easy and simple way. Now first of all we will identify the type of conic equation, which type of this equation is. So for this purpose we will write a general conic equation in the form of ax square plus bxy plus cy square plus d of x e of y plus f is equal to 0. Now our given equation is x square plus 4y square plus 2 of x minus 24y plus 33. In this equation we see that xy, no xy term in our given equation. So no xy term and plus both x square and y square are present, and condition of this is when both x square and y square are present with different coefficients, like with different coefficients. What are the different coefficients? Like this coefficient is 1 and this is 4, 1 and 4. So this indicate an ellipse. Now we will rewrite the given equation and solve this equation by grouping x terms and y terms. So you will write x square plus 2x and the other is 4y square minus 24y and this equation will be equal to minus 33. Now complete the square. By completing square we will get x square plus 2x plus 1, and in this case we will complete the square of this also. Take first of all plus 4 is common, so y square minus 6y, and when you plus 1 here, minus 1 is also then minus 33. So this will become x plus 1 whole square and plus 4 into y square minus 6y will become y square minus 2 into y into 3. It's mean plus 3 square, and minus 1 minus 3 square is minus 33. So you have x plus 1 whole square plus 4 into y minus 3 whole square then is equal to minus 33 plus 1 and plus 9. So minus 33, so when you minus 3 square, so 4 is also multiplied this. So this will become minus 36. So you will add minus 3 plus 1 and plus 36. 36 minus 33 is 3, 3 plus 1 which is equal to 4. So now you will rewrite the equation. Now you have to convert this equation into the standard form of an ellipse, that is x minus h by a square, then plus y minus a k by b square, and that is equal to 1. So this is the standard form of ellipse. So you will convert your equation in this form by divide the whole equation by 4. So divide by 4, you will get x plus 1 whole square by 4 plus y minus 3 whole square by 1, and this is also equal to 1. So this is the standard form of an ellipse where h and k are the centers. H and k are centers and a square is greater than b square. So you can see here h and k are minus h and minus k means your value will be minus 1 and plus 3. And also this is right that a square is equal to 4 and b square is equal to 1, which means that 4 is greater than 1. This is also true. Now we will find the key features of this, that are the coordinates of the center. We have already found out vertices and co-vertices and foci. Now first of all you will find the semi-major axis, that is from the large denominator. Large denominator. So what is the large denominator? We have a square which is equal to 4. So you will write a square which is equal to 4 and a is equal to the 2. So you will find also the semi-minor axis that lies in the smaller denominator. So smaller denominator is 1. So you will write b square is equal to 1, which implies that b is equal to 1. So vertices we will be find are vertices, you should remember that if the major axis is horizontal, means x-axis, a square is under x minus h whole square. So we will write the vertices are h plus minus a and k. This is the condition if the major axis is horizontal. Now I will also tell you if the major axis is vertical, so what will be the condition? So if major axis is vertical, so vertices will be equal to the h and k plus minus a. Now this will be the condition. Now in our question we have this condition because major axis is horizontal. So we will use this and find out the vertices. So you will write the vertices that are h plus minus a and k. So value of h you know -1 and plus minus a means a is equal to 2. You have already find out. A square is equal to 4, so a is equal to 2 and value of k is 3. Now you will got the vertices of this will be equal to the -1 plus 2 will 1 and this is 3 and -1 minus 2 is -3 and 3. So these are the vertices. Now we will find co-vertices. So co-vertices, you should remember that if the major axis is horizontal, if your major axis is horizontal, your co-vertices will be equal to the h, k plus minus b, and if you have major axis is vertical, you will write if major is vertical, then your co-vertices will be such that h plus minus b and k. So we have major axis is horizontal, so we will use this condition. So we will write h into k plus minus b. So the value of h is -1 and the value of k is 3 and b is equal to 1. So you will get -1, 3 plus 1 is 4 and -1, 3 minus 1 is 2. So your co-vertices are -1 and 4 and -1 and 2. Now you have to find the foci. So the formula of this will be equal to the c square, which is equal to a square minus b square. Now c is the distance from the center to each focus. So if the major axis is horizontal, so you will write if major is horizontal, then your focus will be h plus minus c and k. And if major is vertical, then your focus will be equal to the h and k plus minus c. Now we have major axis is horizontal, so we will use this condition for focus. So first of all we will find the value of c. So c square is equal to a square, that is 4, and the b square, that is 1. So 4 minus 1 is 3, which implies that c is equal to plus minus square root of 3. This is the value of c. Now we will find the focus for this. So the focus for the major axis is horizontal. You will get -1 plus minus square root of 3 and k, that is 3. So this is the solution of this question. I hope you understand all the steps how we have done this question. Now we will solve question number 7. Now question number 7 is position vector 3 cos ti plus 3 sin tj plus t square k, find velocity and acceleration. Now you know that velocity is equal to the, when you differentiate with respect to t, so differentiate this function, you will get, you know that dy by dx cos of x is equal to minus sin of x. So you will apply this here, minus 3 sin ti and plus 3 cos tj and plus 2tk. This is the answer of velocity. Now you have to find the acceleration. So acceleration is equal to when you differentiate velocity with respect to time. So dv by dt. Differentiate again this function, you will get minus 3 sin differentiation is cos ti and then minus 3 sin tj and plus 2k. So this is the solution of this question. Now we will solve question number 8. Now question number 8 is find derivative of sine inverse 2x by 1 plus x square with respect to tan inverse x. So we will solve this question in very easy and simple way. So you will solve this question. First of all, write the function, that is, suppose y is equal to sine inverse of 2x by 1 plus x square. You have to differentiate this with respect to tan inverse of x. So you will suppose that z is equal to tan inverse of x and you need to differentiate y with respect to z. For this purpose, you know that we use this identity that sine inverse of 2x plus 1 over x square is always equal to 2 into tan inverse of x. So your y is equal to the 2 tan inverse of x. We have used this identity, so this will make our function more simplified. Now differentiate this with respect to x. So dy by dx is equal to 2 into d by dx into 2 tan inverse of x, and you know the tan inverse of x is equal to the differentiation of this is equal to 1 plus x square. This 2 is taken as common. So you got dy by dx is equal to 2 by 1 plus x square. Now you again differentiate z, which is equal to tan inverse of x. Now differentiate z with respect to x. So dz by dx is equal to d by dx tan inverse of x. dz by dx is equal to 1 plus x square. Now you have to find the value of dy by dz. You have to differentiate y. Y is sine inverse 2x plus 1 plus x square with respect to tan inverse of x. So dy by dz is equal to the, here we use the chain rule. By chain rule, dy by dz is equal to dy by dx and dx by dz. So you got dy by dz dy by dx is equal to 2 into 1 plus x square, and then take the reciprocal of this because this is dx by dz. So 1 plus x square. 1 plus x square is cancelled out and your answer is 2. I hope you understand the question. Now we will solve question number 9. Now question number 9. If f of t is equal to e raised to power t tan of ti minus square root pi secant tj plus 2tk. Find the value of this function at 0, at pi by 2 and 2 pi by 3. You will just put the value of t equal to 0, then value of t equal to pi by 2 and then put the value 2 pi by 3, and the b part state the domain of the function. Now we will solve from the a part. Write the function, that is e raised to power t tan of ti minus secant tj plus 2tk. Put t is equal to 0, you will get e raised to power 0 tan of 0i minus square root pi secant 0j plus 2 into 0k. So 1 into tan of 0 is 0, so 1 into 0 is 0, and secant 0 is equal to the 1, so you will write minus square root pi j, and 2 0 is 0, so this is also 0, so you get minus square root pi j. This is the value of f of 0. Now we will find f of pi by 2. It's mean e raised to power pi by 2 tan pi by 2 I minus square root pi secant pi by 2 j plus 2 pi by 2 k. In this case, you see that tan pi by 2 is undefined. So when you add something to this or subtract, that will also become undefined. So you write f vector pi by 2 is undefined. Now you will solve f of 2 pi by 3. It's mean e raised to power 2 pi by 3 tan of 2 pi by 3 I minus square root pi secant 2 pi by 3 j plus 2 into 2 pi by 3 k. In this case, you know that tan of 2 pi by 3 is equal to minus tan pi by 3, which is equal to minus square root 3. So you will write this function as e raised to power 2 pi by 3 and value of tan 2 pi by 3 is minus square root 3 I and minus square root pi, and secant 2 pi by 3 is equal to minus secant pi by 3, which is equal to minus 2. So minus 2j, and then you have minus minus will become plus in the next step, then plus 4 pi by 3k. So this is the final answer of this. Now we have to find the domain of the function. What will be the domain of the given function? So we see that e raised to power t is defined for all real numbers. Here we will solve the b part. that e raised to power t is defined for all real numbers and tan t is defined for all real numbers, but tan pi by 2 and secant pi by 2 both are undefined at t is equal to pi by 2 plus n pi. So you will write that t must not equal to pi by 2 plus n pi and n belongs to integers. So this is the solution of this part, that he said that find the domain. So domain is where the area where we will solve that function is defined. So this area should not be, when you get tan pi by 2 your answer is undefined or secant. So we will write this as. Now very simple and very easy question. Find all the points on curve y is equal to 2x cube plus 4x square where tangent line is parallel to the y is equal to 8x minus 4. So in this question you have to find the points where tangent line is parallel to y is equal to 8x minus 4. So we will solve this question. So first of all, given curve is y is equal to 2x cube plus 4x square. This is the value of given curve. You will differentiate this. So dy by dx will be equal to 2 into 3, 6x square plus 8x. Now your question line is given, that is y is equal to 8x minus 4. So if you compare this y is equal to mx plus c, you get that m is equal to 8. Means the value of slope m is equal to 8. So you will write dy by dx is also equal to m. So this is equal to 8, which is equal to 6x square plus 8x. Now make this a quadratic equation. So this will become 6x square. So this is equal to the 6x square plus 8x minus 8 is equal to 0. So first of all you will take 2 as common. By taking 2 as common, you will get remaining is 3x square plus 4x minus 4 is equal to 0. So you will make the factors of 12 such that when they are subtracted gives 4. So 3x square plus 4x minus 4 is equal to 0. So the factors of 12 when they are subtracted give 4. So 6 and 2. So 3x square plus 6x minus 2x minus 4 is equal to 0. Now you take 3x as common, remaining is x plus 2 and minus 1 is minus 2 is common, so x plus 2. So you have points 3x minus 2 and x plus 2 both are equal to 0. So the value of x will be equal to x plus 2 is equal to 0, means x is equal to minus 2. Or 3x minus 2 is equal to 0 means 3x is equal to 2 and x is equal to 2 by 3. These are the points. Now we will substitute these values in the value of y. So you will solve this here. Put x is equal to minus 2 in equation 1. You get y is equal to 2 into minus 2 cube plus 4 into minus 2 square. So minus 2 cube is minus 8. Minus 8 into 2 is minus 16. Minus 2 square is 4 and 4 plus 4. 4 into 4 is plus 16. So your answer is 0 when you put x is equal to minus 2. So now put x is equal to the value of x is equal to 2 by 3. So y is equal to the 2 into 2 by 3 cube and plus 4 into 2 by 3 square. You will get by simplifying this 2 cube is 8, 8 into 2 is 16 by 9 plus 2 square is 4, 4 into 4 is 16 and 9, 3 square is 9. So this is equal to the 16 by 27 because 3 cube. So 16, 2 cube is 8, 8 into 2 is 16 and 2 square is 4, 4 into 4 is 16. So 16 by 27, now you will take the LCM, that is 27, and then 16 multiply 3 is 48. So 48 plus 16, you will get 64 by 27. So this is equal to 64 by 27. Now you got the points. You will say that your answer will be, you have to find the all points on the curve. Points are minus 2 and 0 and value of x was 2 by 3 and value of y was 64 by 27. So this is the final answer of this question. Now we will solve question number 11. Now question number 11 is evaluate integral x e raised to power minus x d of x. We will solve this question by integration by parts. Integration by parts. According to this, you have two functions. Let u is equal to the x and the dv is equal to e raised to power minus x d of x. Now you will find du which is equal to d of x and find the value of v which is equal to integral of e raised to power minus x d of x. And by taking integration of this, you will get minus e raised to power minus x, and now apply the formula, that is u into dv, integration of this is u and this is dv, is equal to the product of uv minus integral v du. So now substitute all the values inside this. You will get, put the value of u, that is x, and dv e raised to power minus x d of x. So this is our question. Now u which is equal to x and v which is equal to minus e raised to power minus x, then minus sign of v integration, and value of v is minus e raised to power minus x and du is equal to the d of x. Now again take the integration, minus x e raised to power minus x and minus minus plus e raised to power minus x d of x. So this is equal to minus x e raised to power minus x minus e raised to power minus x and then plus c, constant is also used. Now you can take e raised to power minus x with minus sign as common. You will get 1 plus x plus c. So this is the final answer of this question. I hope you understand. Now we will solve the last question, question number 12. Now question number 12 is Anwar is drawing a car with uniform speed x plus xt. Now you have to find the distance as a function of t and constant when x0 is equal to 2. Now we will solve this question. For A part, given is uniform speed. So speed is represented by v, which is x plus xt. Now you can take x as common, remaining is 1 plus t. Now you have to find the distance. So you know that distance is equal to the integration of v with respect to time. So v is equal to x into 1 plus t d of t. Here we take x as common because we have to integrate this with respect to t. So x into 1 plus t dt. So this will become integration of 1 is t and integration of t is t square by 2. And plus c is also used. So this is the value of distance. Now in the B part he said that find the constant when x of 0 is equal to 2, means your value of t is equal to 0 at t is equal to 0 and other value x of 0 is equal to the 2. So 2 is equal to x into 0 plus 0 by 2 plus c. So you got c is equal to 2 because all this term is equal to 0. So now your function will become distance is equal to the x into t plus t square by 2 plus 2. So this is the final answer of this question. I hope you understand all the question we have done in this video. In the next video, we will solve all the long questions of this model paper. Stay tuned. Allah Hafiz.